Okay, worksheet 23 coming to the end. Now, for number 1, that is actually at the end of the worksheet 22 video. 2 through 4, transmission line has a fixed resistance of 1/2 ohm, and 200,000 VA needs to be sent down it. So 200,000 VA needs to be sent down it at 120 volts. So 200,000 VA divided by 120 volts will give you the current that is going down that power line. And then that power line has a resistance of 1/2 ohm. So when I ask how much heat will the wire have to dissipate, it'll be that current squared times the 1/2 ohm will be the power that it has to dissipate. Now this is known as line loss. So I give you those facts and you solve the problem and you figure out what your line loss is. And so now we're going to take the same transmission wire, same resistance, same VA going down, but now we're going to up the voltage to 12,000 volts, which 200,000 divided by 12,000 will give you the current, and then that current squared times 0.5 ohms will give you the line loss if you use 12,000 volts. And then we will use the same 0.5 ohms, the same 200,000 VA, but now we're going to use 600,000 volts. So 200,000 divided by 600,000 gives you the current. That squared times 0.5 will give you the line loss at the higher voltage. So you're going to work these 3 problems and then you're going to ask the question, power is transmitted using high voltages for what reason? It should be fairly obvious why they do it. And as we wind up the class, we need to talk about low pass filters and high pass filters. A low pass filter and a high pass filter can be made using a resistor and a capacitor. The corner frequency is when the capacitive reactance, or the reactance, is equal to the resistance. So what is the corner frequency for a capacitor of 470 nanofarads, which is 10 to the minus 9, and 1.2 K resistor? So if I go to the spreadsheet and I want the corner frequency for R and C, then my R is 1200, that'd be 1.2 K, and my capacitance is 470 E minus 9. And then I hit the enter, and you see that the frequency is about 282, and that would be in hertz. So 282 hertz. That should be the corner frequency. Now what happens at the corner frequency is you will have a loss of voltage and actually a loss of power. It's actually the half power point. From a voltage standpoint, you lose down to 7/10 or square root of 2 over 2 the voltage. So what I'm going to do is I'm going to show you that, because in 6 through 10 I want to find a capacitor and a resistor that would have a corner frequency between 1 kilohertz and 25 kilohertz. So when I did the calculation, mine came out to be 282, so you got to find a capacitor and a resistor such that your corner frequency is between 1K and 25K. Okay? But I'm going to go ahead and use my 470 and my 1.2, and then we're going to show the low pass and high pass. Okay. So, my VN will be constant. So I'm going to set up a low pass filter and a high pass filter, because here we are as a high pass, here we are as a low pass. My VN will be constant. My V out will change, and what I'm going to do is I'm going to actually use 3 frequencies. Now, when I'm talking about frequencies and I'm talking about a decade, I'm talking about divide by 10 or multiply by 10. So a decade below 282 would be 28 hertz. A decade above 282 would be 2820 hertz. So you move your decimal place when you go decades above and decades below. You make it smaller if you go below, you make it bigger if you go above. And so if we can build these circuits, that'd be great. If we can build your circuit, that'd be great. We're somewhat limited on parts, but you can certainly do it in terms of what I'm about to show you. So we're going to do high pass and low pass. And we're going to do it with a resistor and a capacitor. So this is what I did. I took my 1.2K resistor and I took my 470 nano farad capacitor. And if I look at one side at a time, from the power supply here to the right, this is the low pass configuration. So it's resistor and then capacitor. If I look from here to the left, this is my high pass configuration. And what I did is I labeled this node as my source voltage, which should be 10 volts. And then this node will be my low pass out, because actually you would tap your signal off of this line. That would be my low pass out point, and this would be my high pass out point. Now we know the corner frequency should be 282. We know a decade above, and we know a decade below. So once we set that up, we can go in and do the simulation. And if I do the points or type of sweep, I can do a list, and I can do all of my frequencies at once. We'll see how this goes. 282, whoops, 282, 28.2, and 2820. Decade below, corner frequency, decade above. Click OK. We'll see how the analysis looks. And so now we're going to simulate. Okay. When you do multiple frequencies, you get the graph, and what you're getting is you're going to get the frequency of your high pass. So if I look at my high pass, what you see is at 282, which is about here, almost a third of a kilohertz, my output is up there, or my voltage is up there. Now it's showing a Bode plot actually, and that's because we did the 3 frequencies. So I'm going to close this and just do it one frequency at a time. I think from the standpoint of just seeing this will be a little easier to take. So we're going to do one. So we're going to do one frequency. It's just going to be 282, and we're going to get rid of these. Leave them blank. Okay. So now if I run it, I get my standard output that we're used to. Okay. What you will notice is that I am at the corner frequency for both my high pass filter and my low pass filter. And I said at the corner frequency the voltage out would be about 7/10 of the source voltage. So you get about a 7/10 of a voltage drop. If you calculated the power, you'd be at what we call the half power point. And so I'm at 7 volts. Okay, So since we're using the same components for high pass and low pass, they're going to have the same corner frequency. So at this frequency, everything's the same. Now we're going to close this and we're going to do the 28.2. The 28.2. Okay. Now let's think about this before I hit the go. If my frequency is lower, then my capacitive reactance gets bigger. As my capacitive reactance gets bigger, more of my signal will go out, or I'll have a higher voltage at my low pass out. As my frequency gets higher, my capacitive reactance gets lower, and so my high frequency signals will be shorted to ground. And that's what's happening with a filter. You don't necessarily have a power supply, you just have various signals coming in that you're going to modify, but this is a good place to start. The opposite happens over here. So at a lower frequency, this resistance is higher, so it's going to have a bigger voltage drop across it, and so I will get less out. And then as the frequency goes up, the reactance of this is going to go down, and I will get more of my 10 volts out. And so the sweet spot is the 282 hertz. So this one should be high, and this one should be low when I run it. Okay? So my high pass out, what you see is I'm down to less than a volt. Because I'm at a low frequency, so a high pass filter passes high frequencies. So it rejects low frequencies. It passes high frequencies. And low pass filters pass low frequencies and reject high frequencies. So one of them has dropped to 99.4, the other one is 9.95. And I'm starting with 10, so I'm getting almost 10 out. This one I'm starting at 10, I'm getting around 1 out. Filters are not perfect. They're not like there's a wall. To get perfect filtering, you have to digitize everything, and then you can get perfect filtering. But that would be, we're just dealing with analog components at this point. Okay, so there's my analysis, and that's what we would expect to see. And then if I close it and go in here and edit my simulation command, and instead of 28.2, I go the decade above. So I go 2820. Now my frequency's high, so this should be low, and this one should be high. And let's see if that's the case. And sure enough, now my high pass out is almost a 10, and my low pass out is less than 1. Just less than 1. So I'm getting a little bit of signal through on my low pass, but it's very low power, very low voltage. I'm getting a lot of my 10 volts out on my high pass because the frequency I'm using is above that corner frequency. Okay? So that is low pass, high pass filters with RC, resistances and capacitors. So that is this part of the worksheet. Calculate, and if you can build it and you can measure it, great. Gives you practice moving, changing the frequency out of your function generator. Now, if I can build a I'll stop here. I'll just make another video for the inductive one. Thanks for watching.